In this video, we are going to prove a square. Now, I know in a previous video I showed you how to draw a square, but there's a humongous difference between drawing a square and proving a square. Okay? And this is Euclid Book 1, proposition number 46. Alright, folks. First of all, Euclid says to draw a line from A to B. And then, even though he doesn't directly say this, what you're going to do is you're going to draw an additional line from A to F. Okay? Now, the reason why you're going to do this is because you're going to use centermost part F, outermost part B. You're going to strike an arc. And then, again, you're going to use centermost part B, outermost part F, strike another arc, and they're going to meet up here at C. And when you connect F to C and B to C, what you're going to get is an equilateral triangle. Now, if you draw a line from C to A, you're going to get a line that's directly perpendicular to FB. Okay, CA is perpendicular to FB. All right. Now, what you're going to do next is you're going to say, all radii of the circle are equal, so you're going to take centermost part A, outermost part B, strike yet another arc, and it's going to meet right here at D. Okay? So the length of AB will be equal in size to AD because all radii of a circle are equal. Now, the next thing you're going to do is you're going to chop this triangle up in half. Okay? And when you do, you're going to have a triangle. It's going to be ADB. Alright? And then what you're going to do is by using Euclid Book 1, proposition number 22, you're going to duplicate that triangle right over here. And when you do, you're going to form two more lines. This line is going to be parallel to this one, and this line here is going to be parallel to this one. Okay? And you're going to do it because when you draw out this line right here, you're going to use Euclid Book 1, proposition number 22. You're going to strike an arc here. You're going to strike an arc here because this length is going to be 2 inches. This length right here, between here and here, let me show you, between here and here is also going to be 2 inches. And so you're going to have 2 inch, 2 inch, going to come right up here. And then what you'll do is you'll have these two lines meeting right there. And so this triangle right here will be equal in size to this triangle right here. Alright. Now, we've already established that AC, okay, AC from A to C, is at right angles to AB. And this is by Euclid Book 1, proposition 11. Alright. And we already now know that AB and AD, these two sides right here, are equal in size because all radii of a circle are equal. Now, DE is parallel to AB, and BE, which is right here, BE, right here, is parallel to AD because of Euclid Book 1, proposition number 31. Well, then that makes ADEB a parallelogram. Okay? Now, we can say because ADEB is a parallelogram that AB equals DE. Those are equal in size. Okay, these are equal lengths right here, this one and this one. And then we can go on to say that AD is equal to BE. That means this length is equal to this length. And this is by Euclid Book 1, proposition number 34. And of course we can go on and say that this length is equal to this length, and this length is equal to this length, and so on and so forth, all the way around, because of the transitive property. If this length is equal to this length, and this length is equal to this length, and this length is equal to, and so on and so on and so forth. Okay? Now, we have just now proven that ADEB is equilateral, but we have not proven that it's equal angular. Alright? So, the first thing we do is we say that angle BAD plus angle ADE, the two sums of this one and this one, these two angles right here, the sum of these two is 180 degrees. Now he calls them right angles, and he does this in Euclid Book 1, proposition number 29. You can check that out for yourself. Alright, now, we've already established that BAD is a right angle, and since this here is equal in size to this one, then we can also say that ADE is also a right angle, or 90 degrees. 90 degrees here, 90 degrees there. Okay? In parallelogramic areas, opposite sides and angles are equal. This is by Euclid Book 1, proposition number 34. So that means that angle BAD is equal in size to BED. Okay, so these two are equal. It also means that ABE is equal in size to EDA. These two are equal in size. Okay, and we could go on and on with this. Okay, now we've already said that because they're equal in size, and these are equal in size, that they're all right angles. This is a right angle, this is a right angle, and so on and so forth. Okay? So, ADEB is equilateral and it's equal angular. So if it's equilateral and equal angular, it's a square. So now we can say that ADEB is a square. And that's what Euclid wanted you to prove in the first place. Alright, we have just completed Euclid Book 1, proposition number 46. The next proposition that I cover will be the Pythagorean theorem. And you will not believe what I have to show you on that one. So stay tuned, it gets exciting from here.